Okay, shall we get started? Okay, co-organizers, say hello. Elena.
Hello, everyone. Good to see you all again. And I heard that my audio was garbled last week, or yesterday. So assistant professor of Harvard, thinking about how people can communicate their intent to computers better.
Sarah.
Hi, everybody. Welcome back to day 2.
Hila.
Hi, everyone. Great to see you all again.
Excellent. Okay, hi, I'm Shriram. We want to try something different for today's talk. So we have two things we're going to do. One is we have a Slack channel open that says questions for Stefan Hanenberg. So if you ask a question there, that means you want the question to be asked while the talk is in progress. Okay, so we're going to just do it through the Slack channel because some people, like hands up and down may be interruptive. Also, some people have great audio, some people don't have great audio. So this way, if you can type the question in there, we can then ask the question of Stefan at some reasonable point. Okay, so questions that go there are expected to be questions you want to pause the talk to do. For those of you who are joining for the first time, we have a 10-minute session after the talk proper is over, when you will have discussions in small groups. We would really like to see questions coming out of the small groups. We got some yesterday, but we know there are many more. When we dropped in on the groups, we saw there were several questions, but some of you didn't ask them. So what we'd like you to do, we'd like each group to have like a shared Google Doc or something where you write down the questions. And we really want every group to be asking questions, right? So decide who nominates somebody in your group who's maybe going to do the asking, but you as a group come up with collectively with 1 or 2 questions, nominate somebody to do the asking, and then we'll get through as many of your questions as we can in the last 20 minutes. Okay. Sarah, did you want to add anything to that, or was that good?
Just want to say we are also going to go back over those instructions right before we go into the breakout room. So you will get a reminder.
Yeah, that's right. Now, it is our immense pleasure to introduce Stefan Hanenberg. One could do the usual, academic enumeration of papers and program committees and all that other stuff. But I think something much more important is true of Stefan. I think I first met Stefan at UPSLA in about 2008. And Stefan has been a conscience for our community. Since, for about 15 years now, or perhaps even longer, Stefan has been telling us as a community, the PL community in this case, we really need to be thinking more about our claims. We need to be evaluating them. We can't just make airy-fairy claims. And he hasn't just been telling us that as a voice of conscience, he's been leading it by example. And so I think in some ways he perfectly embodies what this whole swimmer school is about. And Stefan, thank you so much for agreeing to speak. Please take it away.
Okay, thank you very much for your introduction. So, as Rino said, the first typical slide is some advertisement about oneself. So, who am I? So, especially, I think it's not that important because in a few slides, I tell you that you should not rely on authorities or whatsoever. So, in case I have some very convincing things here that make you think that I'm an authority in some topic or in some area, just forget it. So I just want to say, I do empirical evaluations of in general programming or programming language stuff, or somehow related, some things related to programming. Sometimes it's just IDEs or whatsoever. And I do these since a number of years. So I think my very first experiment was started in 2006. And since that time, actually, I don't do anything else. So whenever I do something, it means I run an experiment. And so I did some publications about in the focus of programming languages, readability and comprehension and things. And one of the things that I do is I teach to computer science students here at our department since about, actually, I do not know exactly, something since 10 or 15 years, I can't remember completely, something about empirical methods. And I do this in an additional course to programming language stuff, but also in my programming language course, I give some lectures on empirical methods because I think there is a need to integrate both topics in some way. And I should make it very explicit. I'm in the team controlled experiments. I think Luke will give a talk tomorrow. He'll be in a different team, which is a great thing that I give the first talk, because it gives me the opportunity already to give my arguments why I'm in the team of controlled experiments. Let's see whether my arguments in the end work out or not. So I should start the timer, I think. Just a sec, please. Okay, here we go. So what will you hear? What I try to do here is I try to give a kind of lecture that I typically give in my course on empirical methods, and which is the very first lecture. And the very first lecture just tries to emphasize the problem and tries to emphasize how different we are in our daily life compared to our professional life. And since it's a little bit boring just to speak about motivation, the end of my talk will be the end of my lecture, of my course. So it tried to give you some ideas about what you can do, how you can organize your own research, how you can answer simple questions with relatively reduced effort. So the effort for answering certain questions mustn't be so high. Okay, so the focus, especially here in this talk, is I focus on what is our problem and how large is our problem, because we shouldn't typically, a good talk starts with a problem description whatsoever, but I think it also makes sense to speak about how large is the problem in fact. And at a certain time, I think just one slide or two slides, I speak about medicine, which sounds a little bit strange, because it's just a different discipline. So I don't want to go too deep into this topic for two reasons. The first reason is, as I said, I gave this lecture since about 10 or 15 years. 2 years ago, something's changed. What changed is COVID was on the scene. And suddenly, my students were aware of the need for empirical evaluations. Suddenly, my students they knew the name or the abbreviation FDA, something that I had to explain years before in a number of different ways, and they simply didn't believe what I said, blah, 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 all these things. So I think COVID had made a slight change in our way how we can speak about the topic. And as Shrima said, let's try to make this event a little bit more interactive. So in case you have a question, there is this channel, ask this question. If you have doubts about what I say, articulate them. So in case I say something where you think it's a misunderstanding or whatsoever, just raise your hand and I hope I'll be clarified. Okay, so what is our problem? I think our problem is so manifold that it's unclear how to articulate or how to find a good starting point. But let's try to make the line of reasoning upfront. The line of reasoning that I try to make is, first of all, don't trust in experts. Because there are good reasons why an expert is not the person whose knowledge is based on some evidence, but he became maybe for some other reasons an expert. The next thing is learn to doubt. And this is an essential thing, because for some reason that I until now do not understand, typically in computer science, we are taught mathematics. And there we learn to doubt from the very beginning. And we know there's the moment where a proof is given, where our doubts are no longer needed. The thing is, as soon as we leave the field of mathematics, it looks like our line of argumentation is somehow different. And it looks like we are no longer accustomed to this idea of having doubts or how to articulate doubts or finding the moment where doubts are no longer required. The next thing is what we need to learn is Whenever a certain statement is given, we have to ask for the evidence for the statement. And the second thing that is typically forgotten, and also until today in the literature not that very often present, is ask for the effect sizes for a certain thing. So if a certain technique helps, it's great. But it might be that the effect size is so damn small that it simply doesn't matter. And as I said, the last point is try to understand when a question is answered. So it's like in mathematics, when the proof is given, there's no longer any need to articulate your doubt because the proof is there. The empirical world is slightly different because there is no concept such as a proof. There is no final definitive answer, but we have to learn that there are research methods to answer certain things, and these methods have their pros and cons, and we have to accept when they give an answer. The next thing that I try to emphasize is whenever you as a developer or as a student or maybe in a later step of your career do something, try to make your decisions based on evidence because there are good reasons for that. And the next thing is, and this sounds very simple, but this has something to do with the very last slides in my presentation, is don't be afraid to test simple things. In our field, we find so few statements with empirical evidence that even the simplest things are not really well worked out. And I give very, very trivial examples right now. So, as I said, it's a little bit hard to say how to introduce. And maybe I can give you an idea what I typically do in the first presentation in my lecture. In my first presentation in my lecture, I typically tell a story. And the story is, I have a headache, I go to a doctor, he gives me a pill. What do I do? And what I typically do there is I try to find ways how students typically use a certain situation in reality to check out what their line of argumentation is. So would you take a pill? Why do you take a pill? What do you assume from the pill? What are from you convincing arguments, non-convincing arguments? Are you aware when certain things are subjective whatsoever? So I try to make you, because it would take too long, let's make it a little bit different and let's think about how we learn today programming. So what we typically do is we introduce one specific programming language and we argue that this programming language is great. This is the language that you should learn, and this language is relevant, and this is a language that helps you to find a good job and whatsoever. And then what we do is we give you a number of programming, I do not know how to call them, idioms, principles, guidelines, tools, or whatsoever. For example, we tell, in my case, in my school, we teach Java. And in the very first, or somewhere in the first lectures, we typically say, well, indent your code. And typically students, hopefully students ask why. And the typical answer is, it's better in a number of ways. And we don't really articulate exactly what we mean by that. And it's not only on indentation, it's everything. I mean, programming styles like what variables do you use, or how do you give variables names, or how do you give types names or classes names, or we typically say that we have to refactor code, like look into your methods, it's quite long, try to make 2 methods out of it. And we typically speak about IDEs. I mean, in my school, very, very early, we say something like, well, use Eclipse or use IntelliJ or use whatever, because it's better than something else. And don't forget that code repositories are somehow important and that Git is important and whatsoever. So as I said, in my school, so the things that you typically learn in my school is Java and SQL in the very beginning. And this line of argumentation is very similar, like write your code in a certain way, use certain tools in a certain way, and if anything doesn't work out, use Stack Overflow, by the way. It's a number of, I would say, in a positive way, best practices from your lecturer. So how does teaching work that way? Well, it works because the students think or they trust that I am an authority. And they think or they trust that I have much experience. And they think that my advice doesn't come out of the blue. The interesting thing is the reality check, because when you have a lecturer at the university, you can be damn sure he is not a professional developer. And it depends on the education system. In the German education system, you can be relatively sure he never was a professional developer. So when he speaks about his professional skills, it might be just different than the skill set of a full-time professional developer in industry. The other thing is ego plays definitely a role. I really believe in my development skills. And so does every programmer on this planet. So the problem with that is, just because I'm very convincing or because I find good arguments or whatsoever, doesn't really mean that my development skills are that mature. It just might mean that my rhetorical skills are quite good. What my skills probably are, I can write about software in an academic setting. So I can write papers or I can give presentations, but this is a different skill than being a professional software developer. And actually, my advice is nothing more than a wide collection of something, because it's a private personal tool collection gathered from a number of different sources, which are typically somehow chaotically collected. And I personally believe that the whole academic education must work in a different way, because everything that you find before has something to do with personality, with a person. This is the person Stefan, who has certain characteristics, but just because person Stefan tells you something shouldn't mean that it should mean something to you. So my argumentation shouldn't be something that has something to do with my personality or with my background or whatsoever. So a math teacher's authority is not based on his background. It is based on the proof that he gives. And if he doesn't give the proof, or he's not able to give the proof, then you would say, well, this is probably a problem. So, as I said, the things have something to do with subjectivity. So my tool set that I'm teaching is a personal, private tool set. Maybe the tool set is similar to a colleague of mine. Maybe it's similar to some colleagues from industry, although I'm not 100% sure whether or not, I never tested whether the tool set is comparable. And what I would like to ask you is, oh, we cannot just copy and paste here, right? Oh, okay. So maybe just type in this URL. I mean, just search for spinning dancer on your machine, and let me just check it out. Spinning dancer. Oops. I use just the German one. So it's a known illusion. The interesting thing about this illusion is, so I don't know how many people, so there are approximately 50 people here in this room. A number of those people will see a woman who moves on the right-hand side. And someone of you see it turn the other way around. What's so interesting about that? All of us look definitely at the same phenomenon. All of us see the same picture. We do share the same experience. And still we do see something different. So why do I have this inside this presentation? So It just means subjectivity is damn subjective. Experience is a very subjective thing, and there are good reasons why you find tons of literature on perception, because people can perceive the same phenomena in completely different ways. So if you have a certain programming language in your hand and you think this programming language is completely useless and it's complex, and it might be that your colleague who shares the same experience as you just experiences something different. Although he sees the same phenomenon, although he maybe even comes from the same background, he still experiences something different. So subjectivity is a problem. So if we do rely on our subjective interpretation on things, on technical things, it could just mean that someone is very convinced about the validity or the quality of a certain technical feature, and it might be that a similar person would experience the same thing in a completely different way. And let's say it in the words of Karl Popper, I might be utterly convinced of the truth of a statement, certain of the evidence of my perceptions, overwhelmed by intensity of my experience. Every doubt may seem to me absurd, but does this afford the slightest reason for science to accept my statement? The answer is no. And this is a very essential thing. So just being convinced, or just because having overwhelming experiences, personal experiences, doesn't mean that someone else has to share the same experiences. So with other words, in a scientific world, or in a non-subjective world, we're interested in finding lines of argumentations which do not depend on subjective experiences. And typically at that point, I speak for the next hour about philosophy. I skip it here. I just say there are good reasons why subjectivity is more a problem than part of the solution. So let's try to map it to our discipline. So what's really the problem? Well, the problem is expert opinions could just be wrong. And there's, for example, a well-known study by Brown about teachers. Teachers who are definitely professionals in teaching a programming language. So they are definitely the experts. So what would you expect from the experts? That they know what the problems are of novices. And in the study, I don't want to speak too much about the details, but the whole summary of the study is teachers simply don't agree what the problem is or what the problems are. And even if we would assume a certain level of agreement, this doesn't match the reality. So, and reality is in the study, a data set consisting of millions of programs from novices. Well, expert opinions could just be wrong. And yes, maybe your teacher doesn't know too much about what your problems actually are. The other thing is expert opinions could be just damn expensive. They can cause serious harm. So the Y2K problem is something that has its origin that experts in computer science thought that the programming language COBOL is maybe not worth to be educated any longer. And what was the problem in year 2000? Well, suddenly a huge number of people were required who know the language, and they actually had to do something in the language, and there were not enough people any longer on the market. And we know that the year 2K problem costs about $300 to $800 billion, based on the approximation of certain companies. We do not know how much of this money is actually caused by the technology change, and which of this money was real. I mean, real, like people actually had to fix a certain problem. Okay, I just want to say a wrong person, a wrong expert opinion could be simply problematic. So what's desired? What do we actually want? And well, we want to have facts or strong and independent studies. And after COVID, most people do not doubt any longer about these things. So at least COVID, even in the popular press, suddenly you read something about studies and what the difference is between a pure selection of opinions and studies with control groups and whatsoever. Suddenly it was in the press, and suddenly most of the people were aware of it. And people were aware that even if a well-known person suddenly articulates that you can just heal COVID by, I don't know, drinking a certain liquid, it doesn't mean nothing. Because, well, he might be popular, he might be in the press, and he might be even president of a certain country, but it doesn't imply that he has a certain knowledge about the phenomenon or about any solution. Okay, so actually these things are, we know these from the field of medicine. And actually, if we just speak about now back about programming and programming language and so on, and we would probably assume that we have somehow a comparable situation. So there was a study who studied, for example, how many studies existed up to 2012 about the usability of certain programming language features. And just to remind ourselves, 2012, Simula was no longer in use. It was once in use, and C++ is no longer the leading mainstream language, but it's still on the market. And we have Java, and we have JavaScript, which is about to become one of the leading languages. And we have PHP, and we have Smalltalk, and we have, well, just thinking for 5 minutes, we easily find 20, 30, 40 languages. And we know in this up to 2006, we found, for example, 270,000 studies in medicine. And I would just ask every participant here in this talk, just to guess, what do you think, how many studies were actually found in the whole literature in computer science about the usability of programming languages, where we no longer spoke about inheritance because it's already there?
Do you want people to just type into chat?
Yeah, maybe just type into the chat, and just that we see certain numbers. And we have the comparison in medicine, like 270,000, which gives maybe a first idea what kind of number might be the result.
So I don't know if you can see the number, Stefan, but we're getting 20, 50, 12, 7, 4, 15, 100, 25. I think that's a minus 20, no, approximately 20. Maybe it's a minus 20.
So you're being asked on Slack, are you only counting studies that were published? Is that in itself somehow biased and not trusted, like you were talking about?
Well, actually, it's now a little bit hard to answer this question completely in one sentence. It was a study by someone who said, it should be a usability study with human participants on a certain language construct, no matter what the source of the study is. So this is...
But the bottom line, Stefan, is these are still published studies we're talking about, right? Like not...
No, published, like, do you find it somewhere?
You find in the research literature, right?
No. Do you find it somewhere?
Okay.
Do you find it on the web? Do you find it? Okay, so
I think that was Elijah's question.
I think our participants are slightly biased because the numbers are so damn small. I mean, just to make everyone aware, 2012, it was the situation where the whole planet switched their curricula to Java, where the whole industry switched to Java, where application servers were no longer written in Corba, but suddenly in Java. And do you really think they did it out of the blue? I mean, okay, So the answer was 22. So that was the result of Kayanahu. And this is the moment where I personally think, damn, seriously? I mean, we speak here about a multi-billion market. We speak here about a planet where the leading blue chip companies are the most valuable companies on this planet. Based on information technology written in programming language, it simply means that the evidence, at least the scientific evidence, maybe it's simply not documented, maybe it's hidden somewhere, but it's not available, not foundable. At least Kayanahu was not able to find it. So I think this number is dramatically low. It's not cherry picking. I mean, what I said is, okay, I just spoke about programming languages and programming language features. If we now speak about software engineering in general, there's this a study by Amy Coe, who was searching for the leading publication venues in software engineering and found over a distance of approximately 10 years, altogether 44 studies. And there are a bunch of different studies. They all come up with a comparable damn low number. So just to remind ourselves, we speak about in medicine something like 270,000 studies. Okay, so what do we do? Again, let's remind ourselves, you speak here with one of the experts, and I tell you, forget about the experts. Why? Well, the thing is, the scientific literature that we currently have doesn't give us that much scientific insights. And it's even more dramatic. What's even more dramatic is it's a study from 2016. And the main result of the study was, it was a questionnaire given to Microsoft developers. And the question was, where do you get your information from? So if you have a certain trust in a certain technology or a certain answer to technique, what is the origin of this trust? And the question, I mean, the possible given answers were personal opinions, opinions by a colleague or a boss or whomever. And it could also be scientific literature. And the result of the study was scientific literature was the second lowest given answer in the questionnaire. So the point is, scientific literature doesn't seem to play a major role, even in topics that are, at least to a certain point, answered in the literature. Okay, let's rephrase this. Our professional activities do not rely on scientific facts. This is just the summary of the previous statements. And now let's make a small change in our perspective. Let's assume,
Stefan, there's a quick question for you, I think. What questions do you think are answered in the scientific literature so far? Maybe this is coming later in your talk and you can refer it or whatever.
Well, okay. Actually, they don't come. At least there are a number of things that are addressed. I think the study by Stefan about keywords in programming languages is pretty solid. Some of my studies about type systems, not the early ones, forget them completely. But the later ones, I think they give relatively strong evidence for a certain effect of static types. We have certain in the literature, at least one, when we speak about indentation, and I came about that later on, we find at least one study in the literature that gives us some information about that. But altogether, it's not that much. Okay, so as I said, let's rephrase the sentence. We rephrase the sentence like, our professional activities do not rely on scientific facts. Let's assume we would be physicians. It would imply that we treat our patients because our subjective experience, or it would mean that we ignore scientific evidence. It would also mean that we can invent new medicine or sell new ones without any control. Because this is what actually happens in the software market. So if we do not have anything relied on evidence, this is just the implication of it. So it's not meant to be. People typically tell me that these sentences always sound a little bit aggressive, but I also have the feeling it's just descriptive. Like this is just a direct implication of the things that I previously said. Okay, one thing, by the way, in most countries of this world, you would directly lose your job as a physician. And in certain countries, you would be sued like hell, and it would be a damn expensive thing for you if you work that way, like treat or sell untested medicine is just impossible at least in the Western world.
So Stefan, I think there's a question here about is there perhaps a little bit of a chicken and egg issue? Because you just said there were 22 papers out of tens of thousands of papers. So if roughly one paper a year is being written, then there isn't an evidentiary base. And so unsurprisingly, doctors know that there's a ton of literature. Developers, like, there's obviously no literature. There is literally, to a rounding error, no literature. So why would that be a basis of their judgment? If there are thousands of papers, that might change, right? So these are not fixed facts.
Let me try to answer this in 15 minutes. Because
great, thank you.
In 15 minutes, there is something where I think I show, well, at least
perfect.
You can
and then Elijah can ask his question again at that point.
Okay. So my point here is we can also learn something from medicine. And I do not want to speak about, there's a huge history on science in medicine about experimental designs and great things that happened there. And one thing is very special there. It was about 200 years ago by Pierre-Charles Alexandre Louis. He invented something which was called the numerical method. And what he said is, in medicine, we need to rely on numbers, not on personal experiences. We know today that this numerical method has its problems for good reasons, because modern statistics wasn't yet invented. But the interesting things were the reactions on that. And I added here a number of citations that you found during that time. And the interesting thing is, some of those arguments you find today in the software world, like the calculus could never reveal which particular individual would suffer, blah, 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 and so on and so on. So this doubt in numbers existed in medicine 200 years ago, was quite strong. And this kind of argumentation is something that we can even find today. The interesting thing is, from the history of medicine, we can learn a lot from the perspective of experimentation. So in the medical literature, we find a huge number of experimental designs, so standard designs or data collection techniques, and the most important ones, evidence standards. So in medicine, it is well established what actually scientific contribution is and what is not. And evidence standards, for example, are CONSORT. And just to compare it to our field, up to now, there's just one existing journal in our field that has mentioned a research standard in its call, which is the transaction of computer education. I can't remember. Do they call them today now TOES or
TOES? Yeah.
TOES. Once they called themselves TOKI, and but something has changed. Okay, TOES. Right. As far as I know, it's today the only journal that actually has a research standard mentioned in its call. If you compare this to the literature in medicine, you just take the top 5 journals. All of them have a research standard mentioned there. The research standard that they apply, most of the times it's CONSORT. This is not what exists in the software world. Okay, let's go back to teaching. Okay, what I said today, what I said up to now is, well, we are in a miserable state. And until now, it sounded like I just wanted to blame the lecturers, independent from the fact that I'm a lecturer myself. And what we also have to say is the lecturers do not really have a fair chance to use the scientific literature. And I want to give here an overview of studies that I found on indentation. So I found altogether 12 studies. And so it's not that important. I think the only thing that we need to be interested in is, in this column, whenever you read a yes, it means the study has detected something. And if we just count 1, 2, 3, 4 studies detected something. And the last column here, it means whether the study reported the size of its effect. So just to determine that there is something is more or less useless if I do not know how large the effect is. If we take this into account, there is just one single study left. The interesting thing is, this is not a study in one of our leading journals or whatsoever. It's a relatively small 4 pages paper. And as far as I know, it's the only paper that gives evidence about the positive effect of indentation, although I personally believe that the dependent variable might or might not be problematic. So what's the problem now for a lecturer? Should the lecturer now just to tell the students, well, don't indent your code because we don't find evidence in the literature? So the problem that the lecturer actually has is he has to do something. And to a certain degree, he has to be based on his intuition. But here comes another point. I think students should encourage lecturers to give evidence for its claims. And I think it's not that hard. And it's not even hard for a lecturer to give evidence for certain states, for certain statements. So what can be done? There's now a whole literature on experimentation and whatsoever, but there's one thing that is very, very easy, that can be very, very easily done. The first thing is ask your lecturer just to prepare experiments and to integrate them into teaching. So if your teacher tells you, indent your code, please give us a bunch of examples that shows me that it has an effect. And the thing that you can do is so-called N-of-1 studies. So N-of-1 studies are studies that are executed on a single subject, or at least on a small number of subjects. It's a certain kind of experimental design from the 17th century. And up to now, something about 40% of records in PsychBit, which is in behavioral sciences and psychology, are single case studies. So it's a totally standard way of studying things. Apart from the fact that we don't do it in computer science, and typically if you do it, you will get the argument, well, single case studies don't matter, ignoring the fact that the rest of the scientific world is doing that. The interesting thing about N-of-1 studies is a single subject can experience a certain effect of different treatments. And I just want to give you a small example. This here is just an experiment that I recently did. It's a experiment on indentation. So I don't. There's a URL. You can just click on it, or you can copy it, and you can download a Java application, and it runs the experiment for you. And so the question is just, I want to test indentation, the effect of indentation. So what does the code do? It randomly generates code snippets, and it just asks me what is the result of the code, because the code definitely terminates. It terminates with a integer number, and I can just answer this. The thing is, you can easily just collect the times a single person requires in different treatments. So the result of the study was something like this. Here requires something 3 times more or 2 times more than this one. So when I speak about the effect, about factor 3, I speak here about I rerun the study with a bunch of different people. In the next slide, I just show my own personal data set that I did on my own. The interesting thing about this kind of study is you can do it with yourself. You just need to run, you need to write a code generator that generates certain code snippets for you, and you have to interact somehow with the code snippets, and you can directly do measurements with you. And if your code generator is based on random numbers, even you who wrote the code generator isn't biased enough to overcome the problem of being biased in the experiment. So you can just test yourself as a subject. The next thing is, all these things, these kind of experiments are just simple. They are so simple. It's just a standard design, and you don't require much knowledge in statistics to analyze these things. So I typically just run SPSS over it because I have an SPSS license here in my institute. And so students writing a bachelor thesis with me, sometimes they don't have much knowledge in experimentation. And typically I tell them in about half an hour up to an hour what they have to do in order to analyze this kind of experiment. So it's no great magic that you have to do. You just can do it. And in case you want to read something about it, you even find literature, and you even find at least some books in our field. For example, the book by Klaus Wohlin, Experimentation Software Engineering, also gives you some introduction about experimental designs and analysis and so on. Not about N of 1 trials, but N of 1 is not a difference between to any other experimental design.
So Stefan, there's a question for you here. Yeah. A lecturer's opinions could be described as the results of an N of 1 study on themselves, right? Your response?
Yes, of course. We have here distinguished between two different situations. The first situation is, how honest is an experimenter? So is an experimenter willing in accepting a different reality than which is his own reality? So a serious experimenter will give you just the experiment and say, please just do it. And we speak about 10 minutes about something. And 10 minutes later, he speaks the first time about indentation. And he does it that way because he doesn't want to bias you. If the experimenter tests himself, he wants to do that in a certain way. Just the reason why he tests himself, because he's interested in results. He's not interested in writing papers. He wants to have results, and this is, I think the answer to this question. Okay, what's the main thing of N of 1 studies? So first of all, they give you direct feedback, because it's you who is the first subject typically. And I do them every time when I do a study. It starts with an N of 1 study. And typically we repeat the N of 1 study with a second, with a third, with a fourth person in order to determine what are the expected effect sizes and so on and so on and so on, just to get an idea, what do we currently speak about? And the nice thing about it is, at least in the analysis step, you cannot cheat. So once the numbers are collected, this will be the result of your experiment. So it doesn't no longer play a role what your personal belief upfront was. In the end, you'll have numbers. Okay, they typically help you to understand under what circumstance some technique might have an effect. And the real challenge is to write the code generator, or it permits you to play with different setups. So understanding what are the influencing variables are is relatively interesting. From people from North America, there's, I think, a practical implication. It has something to do with RIB, and I'm not 100% sure, but I assume that you don't need IRB approval for self-experiments. I'm not 100% sure about that, but so you have to check that out on your own. In Germany, the IRB works in a different way than in the States, and which is not that restrictive. So you have to check it out at your institute whether or not the statement is valid or not. So the question to me is, why not simply run a bunch of studies on self-invented technology? Or why not simply run a bunch of studies on talked techniques?
So Stefan, before you go on, there are two quick questions, if you don't mind.
Yeah.
Okay. One question is, for any of these NR1 studies, what does ecological validity look like? Randomly generated code is different from code in the context of a larger system, right? Or at least shouldn't we be checking for that before we can draw any conclusions?
Well, this answer needs time. In the software world, for some reasons, in the first step, we typically ask for generalizability of results. If you take a look, for example, just into the FDA process, the whole idea of generalizability is the last step of a long, long line of research which takes you about 10 years. So the thing is, are you able to identify a certain factor that influences something in a completely artificial environment? If the answer is yes, okay, great, go on. If the answer is no, go into yourself and think about, do you seriously believe in your technology that you invented, if not even you had a measurable effect out of it?
But I think the question about ecological validity is precisely that, right? The no question is also not very meaningful because the context was the missing context was the problem. So in both cases it feels like it's difficult. So anyway, you see the point of the question here.
So maybe we can discuss that later on. I mean,
sounds good.
This question is relatively large. So
yes, it is.
It has a huge number of implications. Maybe in this discussion part we can speak.
Sounds great. Okay, then let me get to the other question. Have you seen full formal specification? Of course, most languages don't have it, for learning languages and measure implementations in studies.
Once more, please.
I'm sorry, I'm just reading out the question. Have you seen full formal specification for learning languages and measure implementations in studies? I think you may have to interpret that a little bit.
Yeah. So my understanding of this question is, I'm not 100% sure.
Yeah.
So does it mean?
Perhaps, Stefan, what I'll do is I'll try to get the question clarified a little bit. You can go on with the talk and we'll see if we can refine it a little bit. Okay. Yeah. Thanks.
By the way, just very few slides left. So NR1 studies, what are the pros and cons? First thing is they're just damn easy to do. When you speak about readability, comprehension tasks, you can run this code, or you can do such experiments over the weekend. You can check different. So if you are an inventor of a programming language, generate experiments with different alternatives of syntax constructs, try alternatives, play around with visual representations. They are just damn easy. If you know, I can collect hundreds of data sets on myself, and you will be very surprised how large effects might or might not be. And even simple questions like, do I have a prefix or a postfix or an infix notation? It can be answered. So, and there's no magic answering these questions. Although our pre-postfix, there's one study in the whole literature that I'm aware of that even addressed this question, although it played, especially for the functional world, a relatively essential role. So you can answer these things. NR1 studies, I think, are typically hard if you have tasks that require a large level of creativity. So the problem is task generation is no longer that easy. It can be done, but I cannot go here into detail. We did this, like natural text generation, where you have text fragments, and you can even do it on yourself. And at least in our cases, it worked out quite well. The hardest part of NR1 studies, and this is just my personal interpretation, the code generator that needs to be written, but actually the task that has to be done. And the task that has to be done means you really need to concentrate on what do you think the effect of a certain technology actually is. So once you did that, well, it's not the end. N of 1 studies are the beginning, and they help you already, and they might give you an idea of an approximation of effect size, and then go for multi-subject studies. And if you have the ability to do that, but the N of 1 study always gives you a first idea, like how large are certain effects and then it means for you that you have an idea how many subjects you actually need inside your study, and you can test different. I mean, you can test language constructs or syntax elements or visualizations, and this is just some advertisements for my own work. So it just tries to give you a number of different works that I did in different contexts that can be done.
Can we interrupt just for a sec with another quick question?
Yeah.
So there's a question about where and how can we get N of 1 studies on PL features published?
He's going to want to take it to the discussion section.
I think that's very reasonable to take it in the discussion session. We can defer if you want.
The PR community is very special. It can be very generalized. If you have a solid experiment, where can this be published? And N of 1 is just the next part of your problem. So publishing a study itself is already today a problem. And maybe this is the question to be aware that the software world is still struggling in the same way as medicine did 200 years ago. So the discussions of what numbers mean, how they can be interpreted, the software world is currently in this situation. What is a valid study? Can you do this interpretation or not? And what does it actually mean? You have to live with that currently. I still encourage people to run studies because they help you. They help you to invent technology that actually helps. Maybe you don't get it published, but you have the evidence that it helps. And it depends on what you actually want to do.
Stefan, I think I have some clarification on that previous question. If we could, do you mind if we go back to that, or do you want to finish up and then we could go back to that?
Yeah.
Okay, so the question is essentially, are there teaching-oriented languages that have static and or dynamic semantics, like formally written down? And do we know anything about the accuracy of the implementations of them?
Actually, at least I do not know.
Okay.
So
I think that's not, I think there are some, but I don't think we should get into that here right now. Yeah.
I mean, yeah. There are some, definitely. It's I mean, I said before something like, okay, at least in the field of type systems, we have something. Yeah. I would say we have in the meantime, I do not know, 10 studies about type systems or static type systems. I assume something like 7 were written by myself. And I still would say we are in the very beginning to address this topic. So having a study here or there, from my perspective, is not, we are far from having any definitive answers. Okay, let's finally say a statement. Why I'm in the team quantitative controlled experiments? Well, because they remove the experimental's subjectivity. And when I said in the beginning, we need to learn to have doubts. It makes sense to have doubts about ourselves as well. So even if you think you have a damn good idea, at the end you collect data and the analysis is no longer in your hands, it will give you a certain answer, if it pleases you or not. And this is the reason why I'm in the team quantitative controlled experiments. Okay, some conclusions. Our literature has problems. Try to avoid the trust in the experts trap. And in the very end, just say, try to train yourself in scientific argumentation, not about plausibility or convincing examples. So try yourself to make the distinction between this is the result of a scientific evaluation, or this is the result of, well, some anecdote, which might be great, but which is still an anecdote. And what I just did here in this presentation is N-of-1 experiments could help. They are not the definite answer to something, but they could help you to guide you through the step of experimentation. And Sriram, you had one question before. So I'm through, but Sriram, you had one question before that I told you that I will answer later on, and I haven't referred to this question.
Yes, so I think this was this the ecological validity of snippets question, or? I think that was the one we left incomplete, but you said you would move that to the discussion section.
So
oh no, there was a question much earlier. Hold on. Just a second. I think it was maybe what, oh no, I think it was this issue of like the chicken and egg problem, right? It's like if there are not enough studies. Yeah, sorry.
Yeah, correct. So the question was absolutely valid. Like, there are no studies. Damn, what can we do? And the thing here is, experiments are no magic. And N-of-1 experiments are the thing that you do during a weekend. You can test yourself what the effect of indentation is. You can test yourself a huge number of things in very similar things. And the thing is, I would like to encourage, to ask you teachers to give you a precise description of in what circumstance a certain technology has one effect, and you can build the experiment for that. And you can measure yourself and later on go to your teacher. Yes, that was my result. Or no, this is not what I found.
So I think the other aspect perhaps of the chicken and egg question was, you pointed out, you showed us, for example, this Prem Devanbu and company study that said developers do not make their decisions, sort of we're living this pre-scientific age, so to speak. But the comment then was, well, if there are no studies, what else can developers base on? Perhaps if we had thousands of studies, just like in medicine, then developers' mindsets might also be very different. And so this is really a bootstrapping sort of circular problem. So it's not that developers are unscientific or something, right? Like as a fixed notion.
Okay.
I think that's how I interpreted, I think, Elijah's question.
Okay, but I personally, so for example, if we go back to, I just speak about these type system things, not because I did these things, but there are at least some studies about that.
Yeah.
And at least what we haven't found so far is evidence that the dynamic type system showed up as a benefit. And we even did a study some years ago where we artificially tried to enforce a benefit of a dynamically typed language. And I think we did something like 5 examples, and only 3 of them turned out to be able to find the positive impact. For the 3 other examples, it was even the opposite. So for me, it is a first indicator that it's time for the dynamic people to show some numbers. So I know the story, like, yes, you can dynamically already run the code, but please show me some numbers.
Yeah. You're basically saying it's starting to create a burden, an obligation of proof, because there's now some evidence in one direction, so there has to be some evidence.
Yes.
What is the argument you're trying to make?
And the necessary thing is also we also have to learn, especially in the field of programming language. In the field of programming languages, we are typically in this mood of, I invented my damn new cool technique. Don't touch my baby. Like, don't say anything bad about my technology. If we switch more into the scientific mode, where we say, well, all of us want to learn something and we want to improve something. Maybe I proposed a certain technology and maybe it worked out in a certain way, but in a different, it simply doesn't work. Why don't I just accept the situation and try to improve something? So I think it has something to do with mindset.
Sounds good. So Stefan, here's what we're going to do. Okay, we're going to send people off into a discussion. We're going to give you 10 minutes. Folks, here's what we want you to do. We want you to spend a minute or two just telling each other who you are, building community. But then we want questions to come out of the groups. Okay, so we're going to take your group questions. We want you to try to maybe write them down, because that may be a little easier. So maybe one person in the group can create a good G-Doc or Google Doc or Microsoft Doc or something, not to offend Andy here, whatever the right technology is, and then share it out out so that you can maybe spend time writing it and then it comes collectively, but also nominate a person from your group to ask the question. We think one of the things that happened yesterday was you all had questions, but it wasn't clear who was going to ask. And so nobody asked. And we want you to nominate a person. Okay. We'll give you a 2-minute warning before we shut down the Zoom rooms, but we're going to send everybody into breakout rooms now. Okay. So give me about a minute to do that. Or 30.
Welcome back, folks.
Hi, everyone. Yeah, so I'm going to ask that people just paste their questions into Zoom, into the Slack channel, and then we can take them from there. I know there are older questions from Kim and Manu. I hope those got incorporated into the room questions. Alexander, I can't tell if yours is a room question or not, so if you could just re-ask it if it's coming from the room. So we'll start with questions from the room and then go to other questions. So questions from the room, could you please paste them in? Several people are typing. Good, excellent. Okay, let's start with this one. Hamad asks, hasn't it been the case that languages are picked up by industry by corporate perceptions of what should be the language or practice to use? Like anecdotally, we've seen people React, Angular, etc., because of industry postings. So Stefan, that's for you.
Okay, so the very short question is, I have absolutely no idea. Let's compare it to medicine, beginning of 20th century. The problem was not that there wasn't many products on the market against headaches. And the problem was not that there was a huge bunch of people who were willing to buy those products. The problem was that it finally turned out that either some of those products simply didn't help, or that they simply killed people. So if you compare this now to programming languages, of course, people have to choose something, because in the end, you have to program your machine with a certain technology. But I personally, I have a very personal perspective on Java. As I think Java is okay. So I'm not in this Java bashing camp. But I think, I mean, everyone who was at conferences at the end of the 90s or beginning of year 2000, you were not able to enter a conference without having 2 or 3 t-shirts, Java t-shirts for free. I personally believe that advertisement plays a huge role. And there are good reasons why you can study marketing. Marketing is, in my lecture on empirical methods, I speak a lot about how to influence perception. I personally believe that it has something to do with these things. And even if we look into programming languages, for example, every now and then you see a language which is the newest shit on this planet, and everyone has to know that. And 5 years later on, it seems it's almost forgotten. 10 years ago, you had to program in Scala.
Okay, Stefan, I'm going to move on to the next question because we've got more questions coming in. So I think we get your general gist from this. Okay, so how could N of 1, and this is on the sort of opposite end, I think a very technical question that I think is about experiment design. How could N of 1 studies be applied to programming language design, both in very small scopes? For example, what should we use to delimit blocks, braces versus other things, and perhaps in much larger changes that are harder to explain quickly. For example, is functional programming good? Is logic programming good? Should we use garbage collection? Should we use generics? So how could N of 1 studies be applied to this purpose?
Studying functional programming. I personally do not believe that we are currently in the situation to be able to study these large pictures in detail. I mean, everyone I know who loves empirical works, all of us want to study the effect of object-oriented programming, and none of us dares to do such a study because we have absolutely no idea where to start. For the moment, I hope these things will be answered in some years. For the moment, I don't think that we can answer that because currently we do not know how to build such experiments. You can do these in very, very small things. So when we, for example, we had at this year's ICSI a study on lambda expressions in a certain context. So it was about usability of lambda collections in the collection API in comparison to the stream API in Java. So this is a way how we studied lambda expressions there. And what we didn't mention in this study is, as we always do, in the beginning, there was an N of 1 study. So these things can be studied in this huge picture, like thousands of lines of code. For the moment, I think, well, this is not the thing where I would use N of 1, because you would lose the benefit of N of 1, like getting a lot of data points in a relatively small amount of time. I hope this answers the question.
Okay, I will let people respond to that and follow up if they want to. So next question is, even in comparing two statically typed languages, instead of say dynamic versus static, how do we empirically argue to find whether the stronger of the two type systems, for example, is necessary? For example, Carbon was recently introduced as successor of C++, but people argue that we should not design a new language based on Rust type system, which is stronger than that of C. So the question is, what would an experiment be like for finding out whether the stronger type system is useful?
Okay, first thing, because it's when we speak for example about Rust type system against any other type system, the languages are damn different. So whether or not, so even if you find some programming tasks in Rust in comparison to, I do not know, some other language, are we really sure that the tasks are about the type system or about something else? So you as an experimenter, you have in the very beginning a problem that you need to get rid of all the additional factors. And for example, we had an experiment on debugging collections, stream API collection debugging and these things. And in the beginning, we built a web page where you just were able to click a certain number of buttons because we wanted to get rid of a number of different effects from different tooling and so on. So my question is, my answer is more, I think we need to think more small-grained. Comparing languages is not that easy. We need to compare language features. Maybe we need to build our own language.
But to be fair, Stefan, the question was about type systems specifically, right? The question was, how would you make, what kind of experiment would one design to make an argument that if you have two languages that are let's say you do things to make things comparable, you want to make an argument, for example, or you want to find out whether a stronger type system is better than a weaker type system. That was the specific question.
Okay, so under the assumption that we really have the identical, languages except the type system. Well, these are the kind of things that I actually did. So like we had this, in my case, it was this Java Groovy experiments that I did. And the people not even knew that they were using Groovy, they just thought they were using Java.
Right.
So find situations where you think there is an effect of the type system in this situation. Let's do two different groups to do these things, find your dependent variable, and you hopefully get an answer or you get a null result.
Got it. Cool. Thank you. Elena?
All right, we have one final question I think we have time for. Well, maybe we can squeeze in two. This one comes from Will Crichton and the group that he was in. And he's asking about the relationship. Well, he's concerned that programming languages doesn't become like a subfield of medicine, which is nutrition. They say, to our understanding, nutrition science has not been able to build a robust theoretical foundation because interventions are heavily contingent on individual variation, like lifestyle choices and small changes in diet, which may not produce significant long-term effects against other factors that influence diet. How do you think PL research can avoid the same trap? That is, to avoid producing valid RCTs that don't ultimately tell us anything useful about PL design or usage?
I think the question has a number of biased implications already. We shouldn't forget that this whole machinery that we have around medicine protects people like hell. And that, yeah, from time to time, there are a bunch of studies that might be not that helpful. This is science. I mean, it doesn't mean whenever a paper is published, it doesn't imply that you get damn new results out of it. And it also doesn't mean just because when we just speak about different kinds of diets and effects of diets, just because there's popular opinion that there are differences, it doesn't imply that these differences are real. I mean, it's like in Germany, for example, we have, I mean, I do not know, 50 years of experiments on homeopathy. And people will start complaining, yes, we haven't found the right experiments yet. And I have the tendency to say, well, 50 years and we haven't found anything yet, gives some kind of strong evidence. So for me, it's not that much. We should leave our typical thinking of computer scientists, like having a study has technique B is the result, let's follow the track of B. And I think it would be helpful if we more think about as scientists who think, let's try to check out what different facets might or might not help. And this is our goal. In the end, industry decides what they want to do.
So maybe we can squeeze in one last question. What are techniques for ensuring a representative sample? And this a little bit relates actually to the previous question. It seems like some way of understanding something about, say, prefix versus postfix notation and so on depends on what kinds of languages people speak, for example. So this is a little bit like the lifestyle choices version, right? It's like, how do we control for those things? So any thoughts you have about this?
Okay, slightly longer answer. If we take a look into the history of medicine, we find that medicine made a huge effort to get rid of certain biases. I mean, medicine was inventing like blind studies or double-blind studies and all these things, which had the intention to get rid of certain influences from participants or even from the experimenter. I think in our field, there are things that we do not know how to handle them, and background information is something that we're struggling with. We have no idea. So, for example, pre-post notations. People are educated in one thing or the other thing, and there might be a certain bias. And I think for the moment we have to live with the problem. So at least I don't have any clear answer to that.
Okay. Okay, really quick question. Where do you publish studies about programming language practices? We heard that software engineering communities are becoming more accepting of these kinds of things. So give us very practical advice on, not the negative side, positive side. What are venues you think of that make sense for this audience to think about?
I think Empirical Software Engineering, the journal, is a damn good starting point. You get their serious reviews. I personally, there is this conference series on empirical software engineering that also exists. There's ICSI also, and ICSI also is from time to time we find papers about programming language constructs and the empirical evaluations. So these things exist. So these are the places where I would submit. I typically would not submit to journals who have more, or even conferences which have more focus on formal definitions. So PL+HCI or ICFP. ICFP probably is not the main address to publish an empirical study.
To be fair, I think the culture is changing, and I think certainly PLDI is much more open to it, and even ICFP is. So I wouldn't want to discourage anybody. Just temper your expectations, perhaps.
No, it wasn't so much about discouraging. So the thing is, you have certain communities which have a certain focus, and if the focus is on formal definitions and reasoning on type systems, type system proofs, and so on, this is their main focus, and their reviewers can come mainly from that.
Yeah, I'm just saying. I think the foci are also evolving. That's all.
Yeah. Okay.
So maybe on that positive, slightly upbeat, positive note, we should end. Let's first thank Stefan for this very inspiring talk and this point of view. And Joe and Justin, are you both here? Do you want to take over? Okay. All right. So well, the organizers, following tradition, will sign off so you people can talk amongst yourselves. And we will see you tomorrow. Be here 10:25 or so. Be promptly here before 10:30 so we can start on time. Thank you. And Justin, Joe, please take over.
Thanks, Stefan.
And thank you, Stefan.
Thank you, Stefan.
Thank you so much for the invitation. Bye.
Bye-bye.